All right, ladies and gentlemen, here is the third video. And so on this one, we're looking at two lovely piecewise functions. We're continuing the first day on functions with Honors PreCal. Okay, so this is a piecewise function. Notice that you can think of this as having 1, 2 pieces where this is an absolute value, and this is a nice little linear function, or you could think of this as having 1, 2, 3 pieces. You can do it either way. They would both be correct. So, okay. On this one, they're saying, what is f of 0? So I need to come down, find where x is equal to 0, and that is this value right here, so that is -2. Then the next thing they say is, what is f of 2? Well, so I'm going to come where x is equal to 2, which is along this line. But notice I have an open circle here. That means it's undefined. That means it approaches that, it gets infinitely close, but it never actually gets to that value. But notice it's jumped up here. They didn't put a closed circle, but they could have. Okay, so if the line does this, then you can assume it's a closed circle and a closed circle. You can assume that. If you want an open circle, you got to put it. Okay, so if I draw something like this, then you know it's open here and closed. It's closed here, whether or not I put that actual little closed circle. So, okay, hopefully that makes sense. Continuing on. Oh, so f of 2 means I'm going to look where x is equal to 2. It's not this value down here, but it is this value here. So the answer is 1. The domain. Okay, well, notice what we did here is we started at -3. We cruised along. We've got everything. We have discontinuity. Notice I have to pick up so like if I'm drawing, I may delete this in a second, but if I'm drawing, I start here, I have to pick up my pencil to continue on right here, but this doesn't change my domain, okay? So, or it's not, okay, let's try that again. What it does is it doesn't give me there's discontinuity here, but the value of 2, x is in my domain. So when I say, okay, what's my domain, I would just go from -3 to, what is that, 5, and then it's a soft, oh, I lied to you. Yeah, my bad. That is a hard bracket. So it goes from -3, and then it goes to 5, and they said, what's the domain? They didn't say, where is the function continuous? Okay, it's continuous from -3 to 2, and then it's continuous from 2 to 5, but that's a different question. Okay, so domain, this is the answer, or you could say x such that, here's how I would say it. Such that -3 is less than or equal to x, which is less than or equal to 5. That would be the same thing in set notation. Okay, notice what I have here. There's just so much going on. If I'm starting to talk about range, notice I go as low as -4, and then on this side, I've got a gap in my range here, but I don't have a gap on this side. Okay, so when I'm finding the range of this, I just go as low as -4 and as high as +4, and it includes both of those. So from -4 to +4, and I could write that again, y such that -4 is less than or equal to y, which is less than or equal to 4. Okay, next thing, write the piecewise function for this graph. You know what, I'm going to clean this up a little bit. Oh, okay, that's annoying. Okay, sorry. Okay. Write the piecewise function for this graph. So I think the absolute value one is a little bit more interesting, so we're going to do it that way, but you could write it as 2 linear functions. So piecewise function, it's f of x, or y is equal to, and then we're going to do brackets around that. So our y value is equal to these multiple pieces going on. So one of them is the absolute value. Well, one of them is just really easy. It's equal to 1. Okay, and when does that happen? You could use interval notation. Typically, I think more often we use from 2 is less than or equal to x is less than or equal to 5. That's when that's true. But now what we need to do is I need to do this top part. I need to describe that absolute value. So, thinking about absolute values, I'm going to come down here, and I'm going to pull in, oh goodness, favorites. There we go. That's not a bad idea for you. If you want to have like a grid as a favorite, then you can just insert that in pretty straightforward, pretty easily. Okay, so there it is. So if you remember, pretend I can draw. Wow, that's terrible. Okay, this, okay, whatever, sorry. That's an absolute value function where its slope on one side is positive 1, its slope on the other side is negative 1, and it goes through. Okay, there we go. Notice what I've done, this in blue, is y is equal to the absolute value of x. What I've done is they've reflected, well, I didn't do it. What they've done is they have stretched it. Okay, so you'll notice that its slope is over 1 and up 2 as opposed to over 1 and up 1. So they've stretched that there, and then they shifted. And we're going to talk more about transformations as we continue, but that's how I think through this one. So what they did, where did they end up? At 1, negative 4. So they need to get, 1, negative 1, 2, 3, 4. I need to get to this point. So and then I have a slope of, so if you notice, y is equal to 2 times the absolute value of x versus y is equal to the absolute value of 2x. If I go to Desmos, you know what? There it is. If I do that, functions. It's miscellaneous. Do you see absolute value? Oh, there it is. Ha ha ha. Okay, absolute value of 2x versus the 2 times absolute value of x. Notice I can turn this one on and off. These are exactly the same. Be careful. This doesn't work for everything. Like I can't say 2x squared and then 2x squared, because what it's doing, that particular operation to it, because it's absolute value, hang on, let me turn this off. Because it's absolute value, those end up being the same thing. And the absolute value of positive 2 is 2, so that works out. Okay, so you could write this either way. I would probably, let's go ahead and do it this way right here. And that would give us a graph that goes through these points. And then it comes this way. Okay, so our absolute value graph is looking something like that. And now I need to shift it to the right one. So y is equal to 2, and then if I make this x minus 1, that's going to shift me to the right, and then down 4, minus 4. So y is equal to 2 times the absolute value of x minus 1 minus 4. Be aware, if you had done it this way, you would need to, and use Desmos to show you that I'm right, you would need parentheses. Okay, if you don't have parentheses, it's gonna shift you. If you wrote this actually shifts you half and not 1. So plug those into Desmos and go see that, and we're going to talk about this more later. I'm going a little too deep for day 1, so sorry about that. Okay, where were we? So we have this 2 times the absolute value of x minus 1. Close that little absolute value thing. Minus 4. But you got to tell me when that's true. And that is true when from negative 3 is less than or equal to x, which is less than 2. And there, ladies and gentlemen, is a piecewise function for that graph. Okay, so the next one, I think we already have enough videos, so we're just going to keep plugging along. On this one, I'm going to add this guy again. Let's move. Can I make that a little small? I can. Okay. So I thought it'd be nice to have a grid. On this one, okay, what I'm going to do to think through this one, we'll do the first one, I'll do the first one in blue. And I'm going to look, they want it to be x is less than or equal to negative 1. So I'm going to say, well, what is f of negative 1? Well, when I plug that in, I get negative 2 plus 5 is 3. So I need the point negative 1, positive 1, 2, 3. And, what did I do? I did something wrong. I needed to make that negative 1, positive 1. You know what? That's too small. Okay, sorry. Negative 1, positive 1, 2, 3. I need to make that, I forgot. My bad. Okay, I don't want that highlighted. Okay, -1, +1, 2, 3. I want an open circle right there. It's got a slope of 2, but I am not defined where I'm greater than -1. I'm only defined this way. So I don't want to try and find those values over there. I just want to go, instead of having a slope of going over 1 and up 2 and ending up here and over 1 and up 2, that's not in the domain of this part of the function. So I want to go back 1 and down 2 and back 1 and down 2 and erase this mess because it's wrong. And then we can do something, pretend I can draw a straight line, and it's doing something like that. The next thing is, let's use a new color, green. We're going to go from -1. We're going to be equal to -2, which is here, and we have a closed circle. And then we cruise along until we get to 1, 2, and we have an open circle right here, and it's just equal to -2. And so there we go. That's all we've got. The next one is a little bit more interesting, and this is just from 2 to 3. So I want to look at f of 2, plug that in, and I get 2 squared is 4 minus 3 is 1, and f of 3 is equal to 3 squared is 9, minus 3 is 6. So if I graph those points, I've got the point 2, 1, and I do want a closed circle. I had to check that because I already did it wrong once. And at 3, I'm at 1, 2, where am I, 6? 1, 2, 3, 4, 5, 6 up here. Okay, now let's think about what this would look like. If you know your quadratics. So this graph is going to be, it's going to be a parabola that got shifted down. So it's doing something like this. So notice we're looking at just this little piece of it, but it's not a straight line. Okay, so you kind of need to make sure that this is curved, but it's a real subtle curve. Okay, so that's a little piece of that graph, and that's what we need. Okay, so now they say, well, find they say f of 2, well, f of 2 is going to be equal to that +1, which we also wrote down a second ago. F of 3 is 6. Find x. Oh, I remember this problem. Okay, find x when f of x is equal to 3. Okay, so that's, here is where, so basically they're saying when y is equal to 3, what does x equal? Well, notice it could have equaled that, but we made it so that it's not defined there. So we want to know, when does the red, oh, I didn't circle this red. Okay, that makes me feel better. We want to know, when does that red equation equal 3? Okay, so I'm going to say, when does x minus 3 equal 3? Well, x minus 3 would equal 6. And one thing that I like to do, keep in mind, a little side note, if I have x squared equals 4, your answer is not just x equals 2. So I have this cheer where I say square root, plus minus. And I'll talk more about that. It's kind of ridiculous. But there's actually two answers where you have x squared is equal to plus or minus root. I lied. X is equal to plus or minus root 6. But that means that would give me this value here and that value there. Well, my little red graph is only defined here at the +1. So the only answer, this equation right here has two answers, but my graph does not. Okay, so be aware of what's happening there. Oh, what am I doing? Okay, so find x. So this answer right here is x would equal square root of 6. State the domain. Okay, let's get a new color. We'll go from -infinity. We cruise along to -1. Okay, we have to pick up our pencil, but we're still defined. Like we're not defined here, but we are defined there, so we're good. Okay, at +2, we're not defined here, but we are there, so we're good. So notice we go all the way to 3. We include 3, and then we're done. State the range. Well, we go as low as -infinity, and we come as high. And notice this gap is taken care of here. Yeah. So we're going to go all the way up to, what is that? I think 6. We include that, and we're done. Okay, that was a lot. Hopefully, most of that was review. Watch me on double speed if you think you don't know it, and then slow it down again when I say something that you're not familiar with. So good luck to you. Let me know if you have any questions.